If I want to find out the latitude at Merpass, there are two things that I need. First of all, I'm going to need the GMT of Merpass, and actually I only really need that to the nearest minute because I'm going to be using declination to find this, and declination is only accurate to the nearest minute. And I'll need a sextant altitude of the body that I'm using, the body on the meridian. So in this case, on the 6th of February at 010403 GMT, I've observed the sextant altitude of Saturn at an altitude of 84 degrees 32.0, so actually a very, very high altitude. What I would also need is an index error and a height of I in order to correct this. So in this instance, my index error is 0.2 off, and my height of I for my dip correction is 10 meters. So first of all, I'm going to find the declination for the GMT. So I go to the daily page, the 6th of February, and at 1 o'clock in the morning, or 1 AM GMT, the declination of Saturn is north 17, 47.5. And my D correction value here is 0.1. And if I turn to the increments tables, for 4 minutes, I can see that 0.1 actually gives me a 0 D correction there, and that fits with what we see on the daily page as well, actually, because we've got at 1 AM the declination is north 17, 47.5, and it's actually steady until 2 AM. So there's no correction to apply here, and that is our final declination of north 17 degrees 47.5. Now for the sextant altitude, we have an index error of 0.2 off, and any error off the arc we're actually going to add on. So first things first, I'm actually going to add that 0.2. So I end up with an observed altitude of 84 degrees 32.2 minutes. The next thing I'm going to do is look up my dip correction for 10 meters. So I'll turn to the front of the almanac, and I've got a 10 meter height of I, so my dip correction is going to be minus 5.6. And 8432.2 minus 5.6 gives me 8426.6. I then need to find my total correction. So again, I'll go to the front of the almanac, and I'm going to look down this column in the centre for stars and planets. There are the apparent altitudes there. My apparent altitude of 84 degrees 26.6 puts me between 8113 and 8703, so my total correction is minus 0.1. Now just note that for some planets there's another correction to apply on top of that. So for Venus and Mars there are these seasonal corrections on the right hand side, so just don't forget to add those in if you need to. But in the case of Saturn there is not an additional correction for that, so we simply subtract 0.1 minutes, and there's no further correction for that one. So we end up with a true altitude of 84 degrees 26.5 minutes. The final stage of this is going to involve us using what we know about our true altitude and our declination in order to find the latitude. It may be easier to work this out if you first of all convert your true altitude to an MZD, and that's exactly the same process as you would use for calculating a TZD if you were doing an intercept method calculation. So the true altitude is subtracted from 90. which gives us an MZD of 5 degrees 33.5. I'm now going to consider the specific formula that I use to get the latitude in this case, and I'll do that by drawing the meridian first of all. So this is my meridian, and I'm just going to mark where the equator crosses that in the middle. So there, I'm going to mark it Q, that's my equator, and I'm going to place my declination and my basically the body somewhere on that meridian, and I'm going to place myself on that meridian as well using my latitude. So I'm actually going to be using my DR lat and my declination to arrange the letter Z for zenith, i.e. based on my latitude, and X for the body, which is going to be based on the declination somewhere on this meridian. So we'll take the declination first. The declination is north, and it's north about 18 degrees, so I'm somewhere above the equator, about 18 degrees above it. You don't have to draw this to scale, it's just to give you an idea of the relationship between the three elements. Looking at my DR latitude, I am north of the equator, but I'm only actually 12 degrees 14.8 roughly, so I'm actually less far north than the body is, which means that I'm somewhere north of the equator but somewhere south of the body, so I'm actually somewhere in between. That's me there. So I've got Q, then I've got Z, which is the observer, and I've got X, which is the body. Next we just have to identify which where my values fit into this diagram. So Q2X is going to be my declination. That's the angle measured at the centre of the Earth between the equator and the body, and that's my declination. ZQ, which is the angle measured at the centre of the Earth between the equator and the observer, that's the latitude in this case, and that's what we're after. So that's the bit we're looking for here. Even though we used our DR to place Z on the meridian, we're actually trying to get an accurate value for this. So I don't actually count that as one of the things I know about this this diagram. The other bit I do know though is my MZD. Now my MZD is the distance from my zenith, so directly above my head, to the body along that meridian. And that is actually represented by the distance from my zenith to the body on this diagram, the Z to X distance. So Z to X is MZD. So I know this. So the declination and the MZD are the two things I know in this situation, and I can actually use them both to find out what my latitude is. I can use QX and ZX to find QZ. So you can see from here that QX minus ZX is going to leave me with QZ. In other words, my declination minus my MZD is going to give me my latitude, and that's exactly what I'm going to do. I'm going to subtract my MZD from my declination to get my latitude. So I'm going to subtract 5 degrees 33.5 from 17 degrees 47.5, and that's going to leave me with a latitude of 12 degrees 14.0 north, and there's a difference in latitude between my DR and my observed latitude of 0.8 south. So my actual latitude that I've used my sextant to find at Merpass is 0.8 minutes south of my DR latitude, which is going to help me if I'm going to use this to plot a position fix.